Hello, I welcome you to this video. We have a question here which requires us to express sin x plus root 3 cos x as a single trigonometric ratio. So this is a question which requires the Euler formula. We know that the Euler formula, we express trigonometric expressions in a form r cos x plus alpha. We can express it in form of r cos x minus alpha, or r sin x plus alpha, and finally r sin x minus alpha. So these are the four different ways how we can express any trigonometric expression as a single trigonometric ratio. So all of them can work, but for simplicity we normally look at the nature of the question. So when we look at it, there is a plus here, so all coefficients are positive, meaning that it's better to use that trigonometric ratio where its compound angle expansion will give us a positive, and that is the cos x minus alpha. This one, we know that this, if expanded, will give us cos x cos alpha plus sin x sin alpha. Now when we use a sign, we can use this one here, because we know sin x plus alpha will give us sin x cos alpha then plus. So when all the coefficients are positive, for simplicity you can use this one here. However, it's not a limitation, all can work. You can use any, and you need to find a way of playing around with the negative signs and the coefficients which you have in the question. So now I'm going to let me use r sin x plus alpha. So we just equate r sin x plus alpha. X is just the angle we are having here in the question, then alpha is that angle which we shall find on the way. So r is the amplitude here, so we shall see how to find this r. So let us say that r sin x plus alpha is equivalent to our expression, which is going to be sin x plus root 3 then cos x. So what we are going to do next is to expand the compound angle of sine. The compound angle of this sine will be r. Then when we expand sin x plus alpha, we shall get sin x cos alpha then plus sin alpha cos x. Now this is still equal to sin x plus root 3 cos x. Now the idea here is to equate the coefficients. Like now from here we have a sin x, even here we have a sin x here, we have a cos x, and we have a cos x here. Don't forget this r, that this r is multiplying the bracket, so it will be here and it will be also in the second term. So here we just equate now the coefficient of sin x on the right hand side is 1, whereas the coefficient here we shall have r cos alpha. So equating the coefficient of sine, we have r cos alpha this one here and this one here are the coefficients. We take it to be the coefficient of sine, so we shall have r cos alpha equal to the right hand side, the coefficient of sine x is 1, and we also have cos x, and it is appearing here, and its coefficient is going to be r sine alpha, and this is equal to root 3. So now this is taken to be our equation 1, and this is our equation 2. So we use these two equations to find the alpha and find the r. So in the previous videos we looked at how we can eliminate a trigonometric ratio. When you have a cos and sine, we just use the Pythagoras theorem of sine squared plus cos squared equal to 1. So I'm going to square both sides and I add. When I square both sides, I'll be having r squared cos squared alpha plus r squared sine squared alpha equal to 1 squared plus 3, because the square of this is going to be 3. So I have to square this side to give me r squared cos alpha equal to 1, and this is r squared sine squared alpha equal to the square of this is 3. So now r squared is common, so we have cos squared alpha plus sine squared alpha equal to 4. This is r squared, but we know that this is a 1. This identity is known now, so we have r times 1 equal to 4. So our r is going to be equal to the square root of 4, and we shall get r as a plus or minus 2. However, in this case we take the magnitude, so we have got our r. Now next is to find the alpha, because we created this alpha. We need to find alpha now. Now alpha, since we have got r, what I'm going to do is to divide equation 1 and equation 2. Now we shall get rid of this r if we divide. So when I divide this equation 2 divided by 1, 2 divided by 1, we shall have r sine over r cos, so we remain with tan alpha. Cos sine over cos is tan, will be equal to root 3 over 1. So alpha is going to be equal to the tan inverse of root 3. So alpha will therefore be equal to, let us find the tan inverse. So the tan inverse of root 3, we have root 3 we get 60. So this is going to be alpha equal to 60 degrees. So remember, we wanted to express it as a single trigonometric ratio, and we chose r sine x plus alpha. So we can therefore say that this is equal to r, which is now the 2, implies our solution will be r sine x plus alpha. So you remove x in the answer, so you have just 2, then sine x plus 60. So this is the answer. So this is the answer which we have got. So it is now a single trigonometric ratio. From here we had a sine plus root 3 cos x.